Okay, now let's talk about how to compress or stretch the sine function. Okay, so it's actually the same way you would compress any graph. How would you compress, right? Square root of x. So square root of x, 0 square is 0, 1 square is 1, square root of 4 is equal to 2. Okay, so the graph looks like this. 4, okay, maybe I can do a little better job making it fit through like that, right? So how do you horizontally compress this graph? Well, this height of 2, I wanted to, if you were to compress the horizontal, I want it to happen here. So at 2, I would like this to be here. Okay, so how would we do that? Well, if I want the graph to be right horizontally compressed like that, do you see? If I just multiply the x by 2x, now into x, right, to get an overall value of a y value of 4, what does x have to be? 2. So multiplying by 2 will make, right, the result of 2 here. I meant square root of 4 is 2, right? Having that multiplication of 2 there will make the y value to be 2 twice as fast, right? So because of that 2, if I just put 2 in there, I get square root of 4. So I get the y value of 2. Okay, similarly, if I have this, and now if I just plug in, instead of 1, I want this y value of 1 to happen twice as fast. And that means we need the y value to be 1 when x is equal to half. And if you replace x with half here, precisely you get root of 1, making y equal to 1. So the result of having this 2 in front of the x multiplied by 2 compresses the graph exactly horizontally by a factor of 2. Okay, so this is something you should already know. I'm just going through the logic with you here, okay, just in case you've forgotten. So what would happen if you put 2x instead of x for sine? Okay, so note that if I put pi in here, I get sine of 2 pi. So at pi, right, we get 0 still. And note that if I put pi over 2 in there, right, sine of 2 times pi over 2, I get sine of pi, which is again 0. And note that if I plug in pi over 4 for x, I get sine of pi over 2, which is, right, which is equal to 1. Okay, so instead of pi over 2, at pi over 4, we're going to have a maximum of 1. All the values will finish by pi, making the full period only length of pi instead of 2 pi. And if you continue this graph until 2 pi, we will get exactly 2 cycles. So this length here, right, is called 1 full period. Okay, so the period here, instead of being a full 2 pi in length, we get half of that length. So the main way to describe what happens to sine function when we have 2 in here, we say the period changes to pi from 2 pi. So if you have, for example, y equals sine of 3x, what do you think will happen? Well, the graph, instead of finishing at 2 pi, now it will finish at 3 times as fast. So 2 pi over 3, this will be pi over 3 only, and this will be pi over 6, and so on. Okay, so in general, the period, right, see this number at the front here? In general, if you have y equals sine of this number at the end, in front here, pi x, okay, let me just put a little box around here. Period is going to be 2 pi divided by k or times by 1 over k. Okay, so there's a reason why I put 1 over k. I mean, you should make a special box around that and make that as a separate note, okay? Okay, let's see what happens if I have sine of half of x. Okay, this number is smaller. So for me to get sine of pi, if I want sine of pi, do you see, because of this half, I actually need the x to be 2 pi, so that this will simplify to become pi. So this has an opposite impact. It will actually stretch the graph twice as long. And remember, the period was 2 pi times by 1 over k. This time, k is half. 1 over k is the reciprocal of half, which is 2. So you get 4 pi as a period, meaning the half has an impact of the sine curve being not ending at 2 pi, but ending at 4 pi, making this here pi and this here 3 pi, 1, negative 1. Okay? All right, let's summarize. Of course, we can do many more examples here, but let's summarize. So if you have y equals sine of kx, okay, if k is, we should say absolute value of k is greater than 1, meaning it's bigger than 1, or actually this actually means k is bigger than 1 or k is small negative 1. This negative here, we'll talk about it separately, but it does still have the impact of stretching, but the negative will also mean reflection on the y-axis, but I'll talk about that separately, okay? But in general, this means compression, okay? Compression by factor of 1 over k, and the period, because of the k, will change to 2 pi times by 1 over k. Okay, if the k value is between negative 1 and 1, which also can be written with absolute value to be this, we get a stretching factor. Stretch by factor of, stretch by a factor of 1 over k. Okay, the period is still the same. This formula will work whether it's, you know, when the k is greater than 1 or less than 1. Okay. All right, so let's do a few more examples in the next video. Let me stop there for the overall summary of what the k does in front of x. I'll see you in the next one.